One picture is worth 1,000 words. Is my AI intelligence tool is actually making any good or just guessing? To find out, I built a custom visual intelligence dashboard for Project Colossus. Today, I'm showing you how to bridge MongoDB with lightweight charts to see the truth behind the data. As you know, I have a market intelligence tool called Colossus. Please join in the channel, the link in the video description. But the most common question regarding it is a performance evaluation. People are asking regarding backtests, paper trading and dashboards. I like graphics and data visualization, so I wanted to see the correlation between AI suggestions and price movement fast. The initial idea was to use the D3 library to draw candlestick charts and recommendations rectangles on top of it. For the candlestick charts, D3 is an overkill. It's super low level and super flexible, but we are building a chart, not a chart framework, right? After a brief research, I have found myself without any choice. Lightweight charts is the undisputable leader in candlestick graphs. You have everything there out of the box. Zoom, pan, candlestick drawer, custom shapes, drawers, canvas API. Now it's only left to draw the chart. The architecture is simple. I have a MongoDB with candlestick data, news aggregations, trading setup advices. And I want to have all this data on the chart. I'm going to use Next.js application to fetch the data from the MongoDB and pass the data to the React frontend, which renders the lightweight charts. Let's build. First, let's install the boilerplate for the Next.js application. I will call it Colossus demo. Let's wait a second for all the dependencies to be installed. Now we have application installed. Let's navigate into the new folder and let's start up the application to check if it's running. Yes, we have application running on localhost port 3000. Now let's install a couple more dependencies. First of all, we're gonna need to install .env. It will help us to read the environment variables from the environment file. Then, of course, we're gonna need to install the lightweight charts itself. Then I'm going to install Lodash. Of course, we're gonna need Mongoose and tiny color to play around with colors. Let's open the project. And I will add to the project the env file and the constants file. The env file gonna store the MongoDB connection string, and the constants file gonna store the constants I'm going to use in the project. I have created the constant file previously, but here I will just explain what I have here. I have in constants the sentiments constants, which are bearish, bullish or neutral. I have defined the chart colors, I have defined the candles intervals, I have defined our default pair, which is going to be price of the Bitcoin in relation to USDT, and I have defined the time intervals in seconds. Now let's read data from the database. To do that, I'm gonna need to define the schema, and I'm gonna need to define the very thin database service layer just to encapsulate the database layer from the logical layer. First of all, in the application folder, I will create the folder called data. There I will create the folder called database, There I will create another folder, call it schemas. I will create another folder called DB services. Nice. For a candlestick schema, I will just copy paste ready to use schema because it's a lot to define and I don't want to waste your time on me typing the schema. Here in the schema, it's important to see that I'm importing Mongoose, I'm importing the infer schema type utility to define the type from the schema, and I'm using the candle intervals. For each candle I have open time, open price, high price, low price, close price, volume, close time, other stuff, important thing, pair, interval. Interval defines the time interval for which one this candle is existing. So we have different candles for minutes, for hours, for days, for weeks. In this particular example, we are working with a 4 hours interval. From a schema, we are defining type of candlestick, and important to know that Mongoose holds everything in a global namespace. So for the hot reload, we should check if the schema is already defined in Mongoose, and only then we should define Mongoose model. I will do the same for a service. I will just copy paste very thin service. Here for a service I have service which has only one function, which is fetch pair candles. What it actually does, it takes one argument of pair. In our case it's going to be a Bitcoin against USDT, and history days of how much days it should look in a history, and it returns the sorted pairs. Also, I need to trigger the Mongoose database connection. For that, I will create utility, and this utility gonna be with database. And what it actually does, it checks if the Mongoose is already connected. So if Mongoose is already connected, it does nothing. If Mongoose is not yet connected, it triggers the connection. In my example, it relies on the config file, so I will have to add the config file. So in config file, I have the environment and MongoDB connection string. I don't need environment, so I will use only the MongoDB connection string. Now let's read the candlestick data from our application. Let's go to the page file, and from it we're going to remove everything what we don't need, and image as well. First of all, let's trigger the database connection. To do it, we will use the previously defined utility connected DB. I'm trying to do a wait, so the home function has to be async. Then I will create an instance of the candles data service, and using the instance of the candle data service, I will fetch candles. I will use pair, so I will require pair from the constants, and I will fetch for last 80 days, and I will show the candles data in the console output. Let's start the server. Call the page. The page is completely empty, simply because we have previously deleted everything. And in the console, we have the candlestick data printed out. Lightweight chart is a client library. So to render the client library, we're definitely gonna have to have the client component. So we have to create the client component. The client component we have created gonna be called the Colossus chart. I will create it in the app folder. So it's gonna be constant Colossus chart, simple component. Now let's tell the Next.js Colossus chart is a client component. Let's render the container for the Colossus chart. It's gonna be a simple div with ID Colossus chart, and it's gonna take full height of the screen and a full width of the screen. To draw a chart, I will use effect. Inside the effect, I will find the container by its ID, and it's gonna be chart container. And then I will define a chart which is gonna to be rendered inside the chart container, and the chart is gonna be of type chart API. Important thing while working with lightweight charts and is to be very careful with types, as they easily can confuse you. Let's import create chart, let's import types, let's add failsafe for a chart container in case if the container not going to be rendered on the page. We have to provide chart options. I will just copy paste them. Now we have chart rendered. To add candlesticks to the chart, we need to add candlestick series to the chart. So we are doing chart, add series, add candlestick series. We are importing it from the lightweight charts, and I'm providing the colors which I have previously defined in constants. Then we need to set the data for the candlestick series, and it's gonna be the candles. We will be getting candles data from the component properties, and we will define the Colossus chart component properties interface. And candles gonna be of type OHLC data, which is data type from the lightweight chart, and now we are getting candles. Now let's pass the candles property from the server component to the client component. To do that, first of all, I will call the Colossus chart component. I have to import component first, and I have a type mismatch between the expected candles type and the candles array which I'm getting from the database. I will have to provide mapping. There are gonna be a lot of mappings, so I will create a utils folder, and there I will create a file called mappers, where I'm going to store all the mapping functions. The first mapper to create is map candles to OHLC. Takes candles represented by my local database type and maps them to the data type expected by the candle chart. I have another utility function called getChartTime. So the getChartTime converts the time, would it be date or number, into the lightweight chart UTC timestamp type. Timestamp represented in seconds. Now we can use mapper to map the data. Let's import the mapper, check the chart, and let's see how the candlesticks are rendered in the browser. Beautiful, we have candlesticks rendered. We have pan, we have zoom, we have everything in place. As you can see, I drove only the candlesticks, and I'm not drawing the grid or any kind of additional information, just to reduce the noise. Now we are going to add the first level of the market intelligence, and it's gonna be market sentiment zones. The grid gonna be colored in a market sentiments. Let's do it. First, I will add another schema called news aggregation. So the news aggregation is holding the amount of news analyzed, brief AI analysis, most mentioned symbols, time range, and most important for us right now, the market sentiment. And market sentiment is an enum, and it holds the three values. Is it market bullish, bearish, or neutral? And as you can see, pretty much standard schema definition and schema binding and type definition from the schema. To query the data, I'm adding another news aggregation service. In this service, I'm having only one function, which is called fetch recent aggregation narrative. Narrative is kind of sentiment. It returns the type news sentiment, which includes sentiment created at timestamp and time range. Important to see that I'm fetching only sentiment created at and time range, because the news aggregation model holds a lot of text data generated by AI, and I don't need this data. I need only the AI opinion stated in the sentiment field. Let's go back to the page component, add the instance of the news aggregation service. Then let's fetch the news aggregations and let's pass the news sentiments to the client component. To do it in a client component, we have to define the property for the news aggregation. I'm going to extend the interface with the news sentiment and read the news sentiments from the property. Let's check if we are reading any news aggregation data. To check it, I will just print the news aggregation data in a console, save everything around, make sure that everything is... Yeah, I'm getting the data. As you can see, there is a time range, sentiment, and created that. Now the most difficult and important part of this video is how to convert the news sentiments into rectangulars. In those rectangulars, we are having Y and X coordinates. On Y coordinate, we have a price. On X coordinate, we have time. So we have to convert sentiments to the time and price rectangulars. Let's provide another mapper for that. Let's go to the mappers file, and there I will add the mapper called map news sentiments to rectangle markers. It will take the list of news sentiments and convert it to the rectangular marker. Important to say, I'm taking the price range. For each market sentiment rectangular, I'm overriding the prices ranges. So I want to have a control over the height of the market sentiment rectangular. So I want each rectangular to be the same height and to be in the background for the candlesticks. When I'm calling the mapper to mark sentiment, I'm providing the news sentiments and I'm providing lowest and highest price of the chart. And I'm calculating the lowest and the highest price of the chart in a simple way. I'm taking the lowest candle and highest candle and adding to it another 10% of their price. There is another thing with the lightweight charts. I'm going to draw the market sentiment rectangulars in scope of the Candlestick series. I'm going to use Candlestick series API to convert the price to the canvas coordinate. And thing is that when I'm rendering the grid of candlesticks, I'm defining the step of X coordinate. Means if I will have a timestamp which is different from any timestamps of the candlesticks, I will not get the coordinate for such point. So I will have to normalize the news aggregation timestamps to match the candlestick timestamps. For that, I will provide another mapper which will normalize the timestamps of news aggregations to the candlestick timestamps. I'm going back to the mappers file. In there, I'm adding a new mapper called normalize chart rectangulars. It takes rectangle markers, and as a second argument, it takes the sorted array of the possible timestamps, and it returns the rectangular mapped rectangular mark. It uses the getGridPoint function, and what it does, it searches using the binary search the closest grid point to the given point. If the point is if the first or the last, it will take the first or the last point of the grid. And now let's apply this normalization mapper to the market sentiments. Now when we have all the data properly mapped, all we need to do is to draw this data on the chart. To do it, we will have to define the rectangular series primitive. It's going to be our custom series primitive, and we will attach this primitive to the chart. Now let's define rectangular series primitive. I will create a folder called primitives. In there, I will create our rectangle series primitive file. In there, I'm going to define our previously mentioned interface called rectangle marker, and I will define the rectangle series primitive, which is implementing series primitive interface, and it's generic from time. What it does, it takes the rectangle data, in our case it's an array, and from this data it renders the pane view, and important to know that it gets a callbacks from the series it was attached. It gets an update trigger, update all views, and once we are attaching to the series, we are getting the link to the series. I will define the rectangle pane view. Rectangle pane view is implementing pane view primitive, and it's a view which renders, which provides the renderer. In our case, it's rectangle renderer. Obviously, I'm copying them. It took for me a lot of time to code them, and I have coded them using AI, with the help of AI. It will just a waste of time for you to watch how I'm doing. I will shortly explain how it all works. So we have rectangle series primitive, and important thing, it getting the link to the series and transfers all the lifecycle events inside, in our case to the pane view. Inside the pane view we have a renderer, and the pane view knows how it should be rendered. So it returns the order of renderer, and it returns the renderer itself. Inside the renderer we have a draw function, and the draw function actually performs drawing. In our case, it gets all the rectangle markers, and for each rectangle marker it draws the marker on the canvas. I have a couple more utilities. It's absolutely cosmetic utilities to draw border lines on the top and on the bottom of the rectangular. It's not relevant for our cases. Let me fix all the imports, and we will see how the pane view with market sentiment is looking on the chart. Alright, I have fixed all the imports, and I have rectangle series primitive absolutely correct. Now I'm using it to attach to the candlestick series. Let's start the server and let's see how does it look. Beautiful. The chart is quite simple to read. The red bars are the areas with bearish market sentiment. The green areas are the areas with bullish market sentiment. As you can see, it's pretty much correlates. When the news are bad, the market going down. Sometimes it goes up for some reason. When the news are positive, market is generally going up. So there is not direct but slight correlation between the market behavior and the price behavior in our particular case for the Bitcoin. I'm driving only the green, so-called bullish areas, and red one, bearish areas. I'm not drawing the neutral market state, just to reduce the noise on the chart. And now, having all the data, the market sentiment and the candlesticks, we can visualize on top the AI trading recommendations, because AI trading recommendations in my case are built on top the fundamental analysis, which is market sentiment, and based on the technical analysis, which is behavior of the candlesticks. As usual, I'm gonna add the database schema. I'm saving all the AI generated trading advices for the performance tracking like we are doing today. For the schema, I will add the service layer to fetch the data from the schema, and in the page component I'm going to create instance of the grid setup advice service. I'm gonna fetch trading advices from there. Then I will add another mapper to map raw data of the grid advices to the chart data, and I will send the mapped data for the grid advices to the Colossus chart component as a property. First, I will add another mapper to our mapper utils. What it actually does, it reads the high boundary price, low boundary price, start time of the recommendation, end time of the recommendation, and it gives a sentiment for the trading advice. Would it be go for long or go for short or do nothing? Now let's extend the Colossus chart client component to accept grid setup advices. To do that, I will extend the interface, and obviously I have to define the interface for the trade setup advice. Then I'm gonna need to map setup advices to the rectangle markers. To do that, I will have to define another mapper, call it map trade advice to rectangle markers. So what actually it does, it takes the grid setup advices, array and maps it to the previously known rectangle marker. Let's import the mapper and extend the properties of the Colossus chart component. Once again, we have to normalize the timestamps of the grid points. Then we're creating a rectangle SeriesPrimitive instance for a trade advice series and attach the trade advice SeriesPrimitive to the candlesticks. And let's how does it look on a chart. It's updated and let's refresh the page. Brilliant. We have trading setups on the chart. I'm very happy with the result. As you can see, the AI advisor advised us to go for any kind of trades only from the 25th of December of 2025, no, 21st of December 2025, and starting from the 19th of January 2026, it started to advise closing the trades, which is red area, or doing nothing, which is gray area. The cool thing that we have a recent price jump, and yet despite the price jump the AI advisor advised us to do nothing, and it's amazing because sometime after the price has dropped back, so we didn't went for a long trade with the hope of this small price jump, which actually proves the idea of the tool. I'm absolutely happy with the AI market movement evaluation and trading advices. The next step is a backtest and recommendation performance evaluation. It's going to be a bit tricky to calculate with a trading grid, but I'm sure AI will help me out here as well. In the age of AI, it's easy to start thinking that AI can do everything for you. No, AI is a helper. It gives you a targeted knowledge and does a routine job for you. You still have to learn and explore to make questions to AI, evaluate AI answers, dive deeper in a constant, check the AI's work results. Keep learning and exploring. See you in the next video about the trading grid performance backtests. Mind your risk management and stay safe. Bye.